Hello, ndikulandireni kuphunziro lathu lalero pamene tikufuna tiyambe topic yatsopano imene tikuitcha kuti graphs of quadratic functions. In lesson 1 tiona drawing graphs of quadratic functions. Basically tikufuna tikhazikitse maziko on how we are going to approach this topic. Ndine Cecil Chuma, GNT Career Remote. Introduction. Tabangapo quadratic function, and we all know that the quadratic function takes this form where a, b, c are constants and a is not equal to 0. Okay, so we make sure the coefficient a or the coefficient of x squared should not be equal to 0, because if this can be equal to 0, then we see quadratic function, because it's a quadratic function because it has a power of 2. So we make sure that the constant a should not be equal to 0. Constant b and c can be equal to 0. So that's a quadratic function. We also know how to factorize quadratic expressions and how to solve quadratic equations by factorizing. Factorizing method to solve quadratic functions. We have also used a method of completing the square, and we have also used quadratic formula. So at this level, Napanga is to solve using graphical methods, which we are going to use in this topic. So far we know 3 methods on how to solve quadratic function: factorization, completing of a square, and by quadratic function. In this lesson, we are going to solve quadratic function using graphs. So in this unit, we will also learn about graphs of quadratic functions, that is, and the properties of such graphs. So today's lesson will set us a very good ground, a very good foundation for us to understand my properties. So we should be together, be attentive, and understand these basics so that we should move forward. You shall learn how to draw and interpret graphs of quadratic functions. So already you know how to draw graphs, but in this case we are going to do quadratic graphs. We'll see how to draw them, then proceed. Continuing with the introduction, we shall also learn how to solve quadratic equations and linear quadratic equations graphically. I already explained this one. We will also know how to formulate quadratic equations given quadratic graphs which cut the x-axis. Okay. Yeah. So the knowledge of quadratic graphs is used in many situations, such as the study of falling objects, projectiles. Projectiles is a thing like, let's say, a missile. If you launch a missile, it detects a projectile. And so these profiles, they use quadratic graphs, the knowledge of quadratic graphs in my situation to understand such situations. Even in falling objects, you use the knowledge of quadratic graphs to understand that. So it's applied in many situations. Economics, physics, a lot of areas where you can use quadratic graphs to understand my situations, also solve my problems. How we can draw graphs of quadratic functions. Basically, it involves drawing a table of values x and y, or for x and y coordinates for quadratic function, and then we plot those values on a set of axes. on a graph paper where you have x and y axes. Now let's have some example on how we can come up with a table of values. Okay, how do we construct a table of values? Now let's assume we have let's say we have y is equal to x squared. This is a quadratic equation which has a is equal to 1, b is equal to 0, and c is also equal to 0. Okay, and another quadratic equation metofunga so demonstrate it's y is equal to minus x squared. In this one, a is equal to minus 1, b is equal to 0, and c is equal to 0. Okay, so for the first one, we know that for us to draw a table of values, we need to have x values and y values. Okay, we have x values and y values. Now, for us to do this, you can be given or you may not be given, but for this one, let's have values which are ranging from -4 to let's say +4. Okay, you can choose any values according to your wish. Okay, so we will have -1, -4, I mean, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, so for this one we need to substitute. Now where there is x, in this case we can say where we are dealing with x is equal to y is equal to x squared, so we can say y is equal to, where there is x we put -4, so it will be -4. So -4 squared, that's 16. Okay, if you check on your calculator, and when it's -3, let's put -3 there. When it's -3, it will be to the power 2, -3 to the power 2, that's 9. Okay, the same -2 squared, that's 4, that's 1, that's 0, that's 1, 4, 9, and 16. Okay, that's that. So that's the table of values for y is equal to x squared. What about table of values for the second one? Y is equal to x squared. We are going to use the same values. So our x values. Our x values and y. Okay. So we can say -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, and 4. So this is our function y is equal to -x squared. So in this case, for us to find the value of y, we're going to substitute -4 squared. -4 squared is supposed to be 16 times negative, that's -16. Okay, then we put there 3, it's obvious we have -9, -4, -1, 0, -1. Okay, that is if we put 1 there. If you square that, it will be 1 negative. Okay, so there -4, -9, and -16. Yeah, so this is how we come up with table of values. So let's make use of this table of values and try to plot these two functions. The function yx squared and y minus x squared. Let's see how they look, and we'll comment a few things. Now let us draw these functions on this graph paper. On this graph, so this was y is equal to x squared, and this was y is equal to minus x squared. So we'll have the two graphs. Remember, let's have our y-axis. This is our y-axis, and this is our x-axis, x, y. Okay, so here we have x is moving from, let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. That's why we have 1, 2, 3, 4, 5, 6. So we have 1 up to 60. Each demarcation represent 1. And here we have 1, 2, 3, 4. And there minus 1, minus 2, minus 3, minus 4. So let us plot when x is equal to negative 4, it's here, negative 4x. What is it, negative 4? Why is it 16? So put a point there. So that's our point. And when x is minus 3 is here. And 9, where y is 9. 9 is here, so it's that point. And when x is negative 2, it's there. And 4, y is 4, which is and when x is negative 1, y is 1. So when x is 0, y is 0. Origin. And when x is 1, y is also 1. X is 2, y is 4. Here is 4. And x is 3, y is 9. Here is 9. X is 4, y is 16. Here is 16. Yeah, let us try to draw this curve. So, 3. Okay, that's the first function, and we are saying this function is y is equal to x squared. Then let us try to draw the second one. This second one, you can see that y is y-axis, and this is okay. Because of the way they are oriented, the figures, mostly we'll use the negative side. So let's do this. So this is our x-axis. So there we have 0. Okay. Then you have minus 1, minus 2, minus 3. Okay, so those are values from negative 1 up to negative 16. There we don't need much. Our x-axis, we have minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4. Okay, so when x is minus 4, y is minus 16. So zikumana apa minus 4 and y minus 16. And when x is minus 3, y is minus 9. So zikumana apa. That's your point. When x is minus 2, y is minus 4. So we come there. Okay. When x is minus 1 and the y is also minus 1, so it's then 0 is minus 0 apa. So that's a 0. Okay. And when x is 1, y is minus 1, so it's apa. When x is 2, y is minus 4. So apa. When x is 3, y is minus 9. Because minus 9 is there. 3 is apa. When x is 4, y is 16. So it's apa. Okay, so we also draw that curve. Sorry. Draw properly. Okay, so it's like that. Now from here we look at the curve that we came up with. This is for the second function as y is equal to negative x squared. Okay, chimene chachitika apa, the graphs are almost the same. Komano tango chitembenuza graph yambayo kuchiyang'anitsa pansi. Now this shape is what we call parabola shape. The shape, let's put it here, the shape is called parabola. The shape is called parabola. Now the parabola is either cup-shaped, it's cup-shaped when coefficient of x is positive, and when it's also cup-shaped when the parabola is inverted, when the shape is inverted. When it is inverted, it means the coefficient is negative. So I think for today, you have to understand the quadratic function graph. This is a simple quadratic function graph. It gives you a parabola, and the coefficient, how does it affect when it is positive? How does the parabola look like? When it is negative, how does the parabola look like? So we have seen that when it is positive, it gives this cup shape. It gives cup shape. Okay, cup shaped. Okay, that this cup shaped, but the inverted cup shaped, it's when the coefficient is negative. Okay, so you can say inverted cup shaped. Okay, so let us understand this behavior of parabola functions. The quadratic functions, which is a parabola, and we have to understand how does the sign to the coefficient of x affects the orientation of your graph. So as it is, let's keep that, as we are going to build on this as we produce the following lessons. Nandine once again Sisoli Joma, tento kumaneso mu video yatu yotsatira zikomo.